Hello students, I am Dr. Amit Bhatnagar, working as Senior Research Officer in the Department of Agronomy at GB Pant, University of Agriculture and Technology, Pantnagar, Uttarakhand. Here, topic is methods to increase water storage in soil. What may be the methods by which we can increase rainwater in soil? And this rainwater is important. If we increase the soil water storage, it means more availability of water to plant. And in rain-fed area, these practices are very important to conserve the water and to increase the soil moisture ability to plants. There are many methods to increase the soil moisture storage, and these methods can be grouped in two categories: biological measures and mechanical measures. Actually, biological measures are cultivation practices or agronomic measures. So these practices are related with the cultivation practices. While in case of mechanical measures, we do some earthwork and make some engineering structures. So engineering and earthwork is involved in mechanical measures. So if there is no earthwork, no structure formation, then other measures are considered as biological. So biological simple methods we adopt in cultivation like tillage, sowing pattern, sowing method, etc. And in case of biological measures, our objective is to increase the infiltration and percolation. Actually, what happens, there is a rainfall, and then if it is not infiltrated into the soil, this is entry is infiltration, and then further lower movement is percolation. So if infiltration and percolation increases, then this rainfall amount increases in soil, and then water is stored in soil and available to the plant. But if rainfall is more and water is not infiltrating, then it start to run off on the soil surface. Now water, very little amount is stored. So very little amount of water is stored means moisture availability is poor and crop cannot survive for longer period. Secondly, this water is wasted. Next harm is that the soil is eroded. So if we check this runoff and increase the infiltration and percolation, then we can reduce the runoff. So we increase the infiltration and percolation to reduce the runoff. If we adopt such practices which are aimed to reduce runoff by increasing infiltration and percolation, then these measures are considered as biological measures. Actually, this infiltration and percolation depends upon the soil properties. Soil physical properties are very important, which decide the entry of water, then further movement. And this physical property, mainly the what is the soil type, and the soil type decide the porosity, and this porosity is decided by density. No doubt, bulk density. So it means what is the bulk density? That will decide the porosity. If bulk density is high, means particles are very close, then pore space is less. So bulk density is inversely related with the porosity. If bulk density is high, porosity is less, it means more pore space is available for infiltration as well percolation. It means we have to increase the porosity of soil. So here objective is to improve the soil physical property as well as chemical property, but major one is physical property, particularly related with the bulk density. So these measures are aimed to increase infiltration and percolation so that more amount of rainfall is stored in soil. Now in case of mechanical measures, here objective is to reduce the runoff velocity, runoff volume and the runoff velocity, so that more time of concentration is available. What is the time of concentration? Time of constraint means suppose this is the slopey area, one slopey area, this is the another slopey area, and this slope is more than this. So water is running very fast, and here water run with less speed comparatively to this one, because slope is high. Suppose slope is further high, suppose like that, then water will run very fast. So if we compare this A diagram with this B diagram and this C diagram, here water is running very fast, so time for infiltration is less. In this case, velocity is less as compared to A, so it get more time compared to A, and here it get more time compared to A and B for infiltration. So this is known as time of concentration, means the time for absorption for infiltration. So if slope is high, then time of concentration of runoff is less, and if slope is less, then time of concentration is more for infiltration and percolation. So it means these are inversely related. Slope and time of concentration is inversely related. So here in mechanical measures, we try to reduce the length of slope, number one. Number two, degree of slope, means suppose this is 20 degree slope, so it is 15 degree slope, it is suppose 8 degree slope. So in mechanical measures, we modify the slope. We cannot level as such. If high slope is there, steep slopes are there, we cannot make it totally level. For example, hilly area, we cannot make the hill as a top plane, but we can modify the slope in such a way that length of slope is reduced and degree of slope is reduced. Means suppose it is 20 degree, then reduced to 15, then reduced to 10, then reduced to 8, and okay. So these are that's why some earthwork is required, some engineering work is required, and these are mechanical measures. So biological measures are cultivation practices, means we do the cultivation in such a way that soil properties are maintained. But in case of mechanical measures, we do some construction soar. So this mechanical measures are long lasting or permanent or semi-permanent or nature. So it means if we do the practices, they leave their effect for a longer time, 2 year, 3 year, 4 year, 5 year, 10 years. While in case of biological measures, effect remain in 1 season or 2 season. It means we have to adopt these biological measures in each season. But in case of mechanical measures, if we adopt this practice, then it can carry its effect for 2 year, 5 year, 6 year, 10 year, depending upon the nature. So these measures, biological measures, do not involve any extra cost. No doubt some cost is involved, but do not have extra cost. But in case of mechanical measures, we have to make some earthwork, we have to do some engineering work, we have to reduce the length of slope, we have to modify the slope. So cost is involved, fund is required. So these are biological measures aimed to increase the infiltration and percolation. While in case of mechanical measure, what is our aim? Our aim is to reduce the runoff volume and velocity by reducing the degree of slope and length of slope. So here our emphasis is to reduce length of slope and degree of slope, so that more time of concentration for runoff water. So these are biological measures and mechanical measures. Now what are the examples of this biological measures and mechanical measures? So this is very important to know which practices are related to biological and mechanical measures. Since these biological measures are cultivation practices, so the first practice is tillage. Actually, tillage, we know that tillage is mechanical manipulation of soil to make favorable seed bed. So tillage exposes the soil. So if expose the soil, then more infiltration, more percolation. So deep summer plowing is very important. And this deep summer plowing is not recommended every year. Once in 3 years. Once in 3 years means after every 3 years, we should go for deep plowing. It is not necessary to have deep plowing every year. So it exposes the soil, and it is done in summer season. In summer season, why in summer season? before the rainy season, before the monsoon. So before rain comes, so go for deep plowing, soil is exposed, then water infiltrate and the large clods that have obstruction into runoff. So this is very good practice. Another practice is subsoiling. What is subsoiling in case of tillage? Actually, what happens, suppose this is the soil surface, so a clay layer or a clay, due to deposition of the clay particles of stone, a hard layer is developed, and then it check the further downward movement. So we have to break this hard layer, and this breaking of hard layer is known as subsoiling. So if this hard break down, then water percolate into deeper layer. So very good example of biological measures is subsoiling. Then contour farming. What is contour farming? We adopt the practices along the contour, means against the slope, means harrowing, plowing, sowing of the crop. If the slope is in this direction, then sowing across the slope. Then strip cropping. In case of strip cropping, erosion permitting and erosion resisting crops are grown in alternate rows, 10 rows of suppose erosion resisting crop, then 10 rows of erosion permitting crop. Cover cropping, they cover the soil and add the organic matter also into the soil. If organic matter is more, definitely more aggregation. Then mulching, it intercept the falling energy, and maybe different type of mulching, organic mulch or vertical mulch. Then conservation tillage. In case of conservation tillage, residue are maintained on soil at least 30%. In case of this conservation tillage, 30% residue are maintained. So means biological measures means those practices, those methods which increases infiltration and percolation, so that rainfall water is stored at the place where it falls. So these are related with the agronomic practice. So sometimes it is also known as agronomic measures. And here, in case of mechanical measures, here we try to reduce the length of slope and degree of slope. So very good example is leveling, level field, bunding, so that water is not moved outside the field, reduce the runoff. Then terracing. Terrace are the earthwork or construction of ridges across the slope. There are different type of terrace. Very common is bench terrace, generally asked in examination. So the slope is reduced in such a way that a terrace, a platform is made, and it is adopted generally in 16 to 33% slope. So this question is asked in generally examination. So bench terrace, maybe diversion terrace, maybe retention terrace, maybe jing terrace. Jing terrace is a different type of terrace. So there are different type of terrace. And other structures, maybe trench formation, trench, and this trench are constructed across the slope, maybe contour trench, maybe continuous trenching, maybe staggered trenching. So contour trench, continuous trench, and staggered trenching. And staggered trenches are made in high rainfall area. So this question is also asked. In low rainfall area, continuous trench are made, while in case of high rainfall area, staggered trenching is done. So these are the different methods. Then grassed waterway. So grasses are grown in the drainage channel, so that water move with the safe velocity, because these grasses obstructs the physical barrier to the velocity, so runoff velocity is reduced. And these grasses add organic matter, so infiltration and percolation increases. Then in biological measure, another is vegetative barrier. Vegetative barriers, actually grasses are grown bunds, and these bunds are made across the slope. So if this and these bunds are made along the slope, across along the contour and across the slope. Since these are on contour, so sometimes these are also known as CBV, contour vegetative barrier, contour vegetative barrier, and also known as live bunds. So these are the different biological and mechanical measures. So biological measures aimed to increase infiltration and percolation, while mechanical measures are earthwork and engineering work with related to modification of the slope. And here infiltration, objective is infiltration and percolation increase. And these are the different examples. Although there are many methods, and other methods may be water harvesting structure. And these water harvesting, in situ water harvesting is adopted then inter-row water harvesting, interplot water harvesting, modified water harvesting come under biological measures. So in situ water harvesting actually increases the soil moisture storage. So if we are adopting in situ water harvesting, in situ, like inter-row water harvesting, definitely in situ water harvesting increases the percolation, soil moisture storage. And ex situ water harvesting, like formation of tank and pond, so this increases the water storage but outside the field, not the soil moisture storage. Here we are discussing about the soil moisture storage. Soil moisture storage, how we can increase the soil moisture in the field. So ex situ water harvesting is related with the storage and conservation of moisture outside the field, and this water is available for many purposes, for irrigation, for drinking, for livestock, for domestic purpose, like pond, huge quantity of water is formed. So in mechanical measures, we adopt the practice in the field in such a way that the runoff velocity and quantity is reduced, and more water infiltration, more time of concentration, so that soil moisture ability is increased. So don't be confused with the mechanical measures and ex situ water harvesting. In case of ex situ water harvesting, we make some structures like tank, pond, sunken pond, khadin, anicut, check dam, small dam, and these are the water reservoir. So ex situ water harvesting practices actually are related with the construction of water reservoir, where huge quantity of water can be stored for longer period. But here our topic is soil moisture storage. Soil water storage means rainwater is stored in soil. How we can increase the quantity of rainfall into the soil that remain for longer period and more quantity remain in soil, so that the existing crop, present crop can survive and may leave the residual moisture for the next season. So actually rainfall is in Kharif season. If we increase the soil moisture storage, then it will provide the water for the Kharif season crop. If there is a good quantity, then it can leave the residual moisture for next Rabi season crop. So these practices are aimed to increase the soil moisture storage. So these are different practices. Thank you very much.